Hi, my name is Sky, and I'm trying out one of these vlogging things because they sound awesome. I'm here today to talk to you about a wonderful little condition called achromatopsia. You spell it achromatopsia, okay? It's nice and complicated. What is it, and why are you talking about it? Well, my friends have it. Achromatopsia is a really rare disease because it's one of those recessive things where both your parents have to have the gene to make it work. Because if you have the dominant gene, which is the normal gene, then you don't have it. You have to have two really rare genes. So what is achromatopsia exactly? First of all, you have to know that someone who has achromatopsia isn't completely blind. There's kind of this thing going around that you're either blind or you can see, and that's not true. I don't know where that kind of came from, because you can definitely be what's called legally blind, which is where you can see, but legally you're not allowed to do things like drive cars, and you also usually have issues getting around because your vision isn't reliable. Legally blind is defined by a field of vision of, I believe, 20 or less, or having 2200 visual acuity. Achromatopsia is kind of interesting because it manifests itself in different ways. Some people, it's pretty rare, but some people can have part achromatopsia, where their vision is actually better than 2200 and they're not considered legally blind. Some people, like me, have 2400 vision and are considered very legally blind. The thing about achromatopsia is that, apart from the visual acuity, it also has to do with light sensitivity. Light sensitivity, or photophobia, and no, that doesn't mean I'm afraid of pictures. I get that a lot. You're really, really bad with light. Light in your eyes don't work. You're probably noticing that I'm squinting a lot while I'm taking this video. I'll try not to, but it's really hard because it's bright. For me, probably not for you. So I'm squinting a lot because my retinas don't have any cones. And from your grade 9 biology class, you probably remember that your retinas have two types of cells, cones and rods. My cones aren't here. They're gone. You either don't have any cones at all, or the cones you do have don't function properly. That means that your cones, which are responsible for seeing color and filtering light and seeing all of your detailed vision, aren't there. That, of course, leads to complete color blindness, which we are going to talk about later. That's an important subject. It also leads to things like the low visual acuity, which I talked about. One other thing with visual acuity is I can't see things far away, but that doesn't exactly mean I can't see them close up. We can read normal size font if we're really close. Usually. I mean, it gives us terrible eye strain because we'll be squinting like crazy, but we can do it. By really close, I mean when we're reading something, we have to be about this close to properly read it. So you'll see us on our computers and stuff, you know, being really, really close to our computers, and like I had comments from friends, they're like, "Are you eating the computer screen?" And I'm like, technically, I suppose you could say that. They're dummies. But yeah, we have to be really close to things, and that's why our vision sucks. That's the point of this video, isn't it? But we can do things detailed. We can write, we can draw, you know, magnifiers do help. Adaptive technology helps. In general, like I draw, and I usually don't need anything special. I have to be about an inch away from my paper when I'm doing it, but yeah, I'm good. I can work it out. I draw stuff. I make a comic. I'll have to introduce my comic later. Oh, if you're wondering, I have a dog. You want to see him? Yeah, you do. You want to see him. This is my dog. He's making all the noise. Isn't he cute? He's really old. He's like turning 16. He's not going to be around for much longer, so say hi. Say hi. Hi. This is probably his final debut. Now, light sensitivity is probably the most important thing that I can talk about because it affects us the most, probably, as people with achromatopsia. And that is because when we're outside, or even inside like I am right now, in moderate lighting, our vision goes way down. Remember how I probably mentioned earlier on that I have 2400 vision? That's in my best lighting, which is dark, like really dark, like all lights off, dark. Obviously, around the world, you're not gonna have that kind of wonderful accommodation of lighting because most people can't see when it's dark. And before you ask, no, we're not nocturnal. we can't see perfectly at night, but we can see definitely the easiest at night because the cells that we do have in our eyes work really well at night. I mean, that's what they're meant to do. You have them too if you have perfect vision. They work. They just aren't affected by the sunlight that burns. We're like vampires. Light burns, yeah, it hurts a whole lot. Even looking at this screen, yeah. We get eye strain a lot. Eye strain sucks. Eye strain's awful. It's like having a little teeny tiny headache all the time. Yeah, we get eye strain, but you live with it. When we're outside and it's light out, our vision goes down a lot. I mean, it's kind of a game of blinking. You know in the movies where you see like an explosion and it's really, really light, it's like a filter of white, and you can't see more than a few feet in front of the character and everything's like really white and misty and there's no details? Well, that's what it's kind of like for us. And so we step outside and we can't see almost anything. Well, actually we can't usually see anything at all. Unless we have our sunglasses, then we can see a little bit, but not a lot, definitely lower than our normal visual acuity. So what's this whole blinking thing about? Well, our eyes can only take in a teeny tiny bit of light, and so we blink and we wait for our eyes to register what we see outside because those rod cells need to work extra hard, right? So we'll walk, we'll blink, we'll wait for it to reset, we'll walk, we'll blink, and so being outside is really, really tedious trying to get around and stuff because not only do you have to deal with not being able to see very well, not being able to see things that are really close in color, or a shade in our case because we can't see color, or things that blend in because we don't have very much depth perception, which I'll also get into later. We also have to deal with all of this not being able to see because we're blinking. Let's take crossing a street for an example. How do you cross a street when you can't see the traffic light, which we can't because our visual acuity sucks, and it sucks even more outside, and we can't see colors anyway, even if we could? Yeah. So what we do is you go by the parallel traffic, which is the traffic that is right by your side, right next to you, that's going straight with you the way you're going, and you wait for the traffic to go, and right as soon as that traffic goes straight and doesn't turn, you can go with that traffic, and it's listening usually, and with people with achromatopsia, it's a little bit of seeing. You can kind of see that traffic, but what I'm trying to explain is that you can't see it moving because you have to blink, right? So maybe you'll blink once and you see that the car next to you has moved maybe a few feet forward, and you'll blink again and you'll see there's a kind of blurry thing that moved a few feet more, and you'll blink again and you can't see it anymore. You know, there's no movement because it's gone out of your field of vision because it's so bright, right? You know to go with the traffic at that point because you've heard it go as straight as you can, and you have to hope that you're being right and your senses are not betraying you, and you go forward with that car. But that's what I'm trying to say is outside, when we blink, we can't see things moving at all, really. I don't know of anyone with achromatopsia that can, but then again, I don't know too many people with achromatopsia that is fully manifested. So, other than the whole blinking thing and the whole light sensitivity thing, I was going to get into depth perception and color vision. They are related. Yes, they are. It's a big myth in the world that there's no such thing as completely colorblind. That is a lie. I tell you now, they are lying to you because I am a complete example. I have no clue what a color is. I have never seen a color in my life. I don't know what a color is. I have no clue what a color is. So I see the world in shades, different varieties of dark and light. And I don't know if I'm seeing in grays or blues or pinks or greens because I've never seen any of those colors. So I don't know which variety of shade of color I'm seeing in. I'm guessing gray because I can't pick up on colors if I don't have any cones, but who knows? Who really knows? And it's very interesting because I see the world in all these different monochromatic schemes. That also takes away from a lot of the depth perception and a lot of visual acuity, because a lot of the times things that you could make out because it's a certain color, say a tree branch because it's vivid green or the leaves are green, so I've been told, I can't see that they're green. I can see that there's a big cluster of medium shaded things. Say you're in a field and there's a tree and it's you know, all surrounded by grass. I can see that there's something there, but I can't tell the branches apart from the grass unless I'm really, really, really close, because they look the same color. It's like they blend together. It's like the world's a chameleon. So the same with curbs and stuff like that. I might have the visual acuity to see it when I'm right up with the curb, except that the road and the curb can look like the same color to me, or not color, shade, grayscale thing. So that's where you get all those issues with tripping and stuff. And that is actually even worse at night, because you'll be walking and all those shades that, you know, kind of stood out with each other in the daytime, well, at night they don't, because all the shades get darker. Everything gets darker. Say it was a really nice dark paved road and a really nice light sidewalk, and I could tell them apart at day. Well, at night, the sidewalk is really shadowy and dark, and so is the road. And so how do you tell them apart? They're the same color. Can you guys see colors at night? Do they stand? I've never asked anyone that. Vision people. So, what have we covered? Colors, which I can't see. We've covered light. We've covered visual acuity, kinda. Nystagmus. What's nystagmus? Nystagmus is something that we have too, usually. I don't know why we have it. Weaker eye muscles or whatnot, I guess. I don't know why we have weaker eye muscles. It doesn't have to do with your retina, but nystagmus is when your pupils in your eye and stuff go back and forth, kind of like a pendulum. People see it, they freak out, they think it's scary or something, so they'll look at you and they're like, why are your eyes twitching? It's nystagmus. We can't tell. It doesn't look like the world's going back and forth. It's just how our eyes look, they twitch. So I think that's it for now. It's my first video introducing, you know, what achromatopsia is. If you have any questions, I'll get into other things later, like mobility aids and stuff like that, daily living, or more stuff about achromatopsia if you need it. So thanks for watching, and I'll see you guys later.